Hello and welcome. My name is Ian Riley, and I'm bringing you a whole new series on competitive programming, which will be hosted here on YouTube and later through a combination of both YouTube and Twitch. Everything that we do as a part of this series will be publicly available on GitHub. But what is competitive programming? If you're not familiar with the concept of competitive programming, it is the exercise of writing programs to solve algorithmic puzzles. Typically, these algorithmic puzzles are characterized as having some prompt with a well-defined input that's provided on standard in, and then you have to write a program that takes that input and produces a desired output on standard out that solves that particular challenge. Now, competitive programming can exist in the untimed and timed form, and most of us are familiar with the untimed form. These are the kind of problems that you find on places like LeetCode, TopCoder, CodeChef, HackerRank, and the various other platforms that do the same thing. And we're familiar with these because developers have to prepare for technical interviews, where technical interviews are essentially examples of competitive programming, although we might say that they're examples in the timed fashion since you do have a limited amount of time for your interviews. These interviews focus on algorithmic knowledge, data structure knowledge, and logical applications of programming, which is effectively what you have to do for algorithmic puzzles. In the timed space, though, we largely talk about students competing in a timed format against other students. This would be examples of college students competing in the International Collegiate Programming Contest, where they compete in groups of 3 to solve somewhere between 12 and 14 algorithmic puzzles in 5 hours. It is a real marathon. And at the high school level, we have high school students competing individually and as teams in things like, for example, in the United States, we have the USACO, or the United States of America Computing Olympiad, in preparation for the IOI, which is the International Olympiad in Informatics. And it can be a really great opportunity for high school students to be able to participate in these contests, as well as for college students to participate in their own collegiate contests. So, a little bit about me though. I'm an instructor in computer science here at a local university in Tulsa, Oklahoma. I actually coach students in both ICPC and USACO. So I coach students at my university to prepare them for ICPC. We have a ton of fun doing it. We have regional, national, and international contests, and I hope that one day we'll be able to compete at all of those levels. In addition, I volunteer at local high schools to prepare students for the USACO contests, and those are also, we've kind of just gotten those started, but it's been a real joy to be able to do those as well. So what I'm hoping to do as a part of this series is to help supplement the work that I'm already doing to prepare high school students and college students for the contests that they're engaging in, as well as to provide content that would help other developers to prepare for their technical interviews. So we'll be solving key examples of problems from ICPC, USACO, and other platforms in a variety of languages. Now, the two languages I'm going to focus on first and foremost are actually going to be a combination of Rust and Java, so just hear me out for a second. So number one, Rust. I really enjoy programming language Rust. It's a lot of fun, and I think it could be a key language for competitive programming in the future, so I kind of want to show off what it can do. Now, I know that right now it's not used for competitive programming, at least not in the student contest fashion, but the problems that are available online right now can actually be solved in Rust, and I think it'd be really cool to see what that's like, because I've never actually gotten to solve most of them in Rust before, so I'd like to go ahead and take that exercise. And for developers out there that like Rust, I think you'll really enjoy it. And for those that have never seen it, I think it'll be a really cool exercise. Now, Java. I know many of you are probably already turning this off because you're hearing the words, we're going to solve these in Java. But it's important that we do so, because for those that want to compete in the high school contests, you're actually kind of tethered to Java. Not because of the contest. Most of these contests also accept C++ and Python, although there are still many developers that are hearing that and they're just like, why can't we have more languages? But that's what they use. Unfortunately, AP school boards for high schools in the United States actually require students to be tested in Java, so it behooves most high school students to both do USACO and their AP exams in Java, since one of them does require it. So we're going to focus on those two languages, focusing on Rust, where we're focusing on ICPC problems and other platforms, and Java if Rust is not available, or if we're focusing on USACO problems. Overall, I'm really excited about being able to do this series. Ever since I had dreams of starting a YouTube channel, I knew that this is what I wanted to do, and I've been sitting on it for a long time, largely because I just haven't had the time to work on it, or really the opportunity to. And I've also kind of wondered, like, what would this platform look like? And of course, I've kind of had kids along the way and had to start, scheduling time in which I can work, in which I can record. which also led to the development of the name of this channel, Late Night Code, because the best time for me to record is actually after my children have gone to bed, and typically about 9, 10, 11, sometimes midnight. And thankfully I'm a night owl, so that kind of works for me. But this provides now an opportunity for me able to do something that I really enjoy and honestly really love. It's been a huge pull for me in the space of developing algorithmic puzzles and solving them is one of the things that I enjoy most about my field. And I think it's also something that can really help challenge us all to grow in our knowledge of development, in particular the application of our fundamentals, and they're called fundamentals for a reason. So I really hope and implore you to join me in this journey. I think that you're going to get a lot out of it, and I think that we're going to have a great time doing it. So until that next episode, have a great night, and I'll see you then.